Hello, I'm going to really try to keep this to under 5 minutes. Just wanted to give you a couple hints on the take-home test. Make sure you look where it says calculator versus no calculator. So number one is a no calculator question. Do the slope field. If you've looked at part B, while the slope field in the part A is drawn at only 12 points, it is defined at every point in the XY plane. Describe all points, not just the ones on the graph, for which the slopes are positive. So what I mean by part B is when you look at your differential equation, I want to know when is this going to, dy dx's slope, right? When is that slope going to be positive? So in part B, you need to tell me, in general, what has to be true about x, what has to be true about y for this whole expression to become positive. That's what I'm looking for B. Now in C, I ask for a particular solution to this, and I give you an initial condition. It's a separable differential equation. And I don't want to do the exact one on here, but I will do one that's very close to it. So just as an example, because the algebra is a little weird, let's say this was my slope field. Dy dx equals x cubed times y plus 5. That's not the one you have. But let's say it was. And I wanted to solve it with the initial condition that, let's say f of 0 equals 1. Here's how I would do it. Separable differential equation. First step is separate. So if I move the dx over, I have dy equals x cubed times y plus 5 dx. I divide by y plus 5. dy over y plus 5 equals x cubed dx. There's the separate part. Next is differentiable. So take the antiderivative of those. The right side's easier. X to the fourth over 4. Think of this as 1 over y plus 5. When I have 1 over y to the first, what's the antiderivative? Good, ln. So this would be ln, but not just the ln of y plus 5, ln of the absolute value of y plus 5. Now technically you would need u sub, let u equal y plus 5, but what's the derivative of y plus 5? Just 1, so I don't really need u sub. You do need a plus c. It doesn't matter which side you put it on. I like to put it on this side. Now before you solve for y, use the c value at this step to figure out what that c is. So now do initial condition and say, okay, if x is 0, y is 1. So ln of absolute value of 6 equals 0 over 4 plus c. Here I can drop the absolute value because ln of the absolute value of 6 is just the same as ln of 6 equals c. Okay, so plug that in. I have ln of the absolute value of y plus 5 equals x to the fourth over 4 plus ln of 6. Now we did the separable, differentiable. What's my last step? I have to solve the equation. So I need to get y alone. And this is where it gets a little weird. To get y alone, I have to take exponentiate by e. Now this is still absolute value of y plus 5. This is e, all in the exponent, x to the fourth over 4 plus ln of 6. You can leave it like that, but it's kind of ugly. This is the same as absolute value of y plus 5 equals, do you believe that this is e to the x to the fourth over 4 times e to the ln of 6? 2 logs multiply, or I have the same base, e. So when I'm multiplying with the same base, I keep the base, add the exponent. I just switched it like that. Because then this goes away, and I have absolute value of y plus 5 equals, that's just 6, e to the x to the fourth over 4. We did something like that when I derived that y equals ae to the kt equation. Now how do I get rid of the absolute value? Well, if you want to drop the absolute value when there's a variable, you need a plus or minus. So this is plus or minus 6e to the x to the fourth over 4. And then subtract the 5, y equals plus or minus 6e to the x to the fourth over 4 minus 5. Final step, how do we figure out if this is positive or negative? Well, use your initial condition. When x is 0, y should be a positive 1. So if I plug in 0, 6e to the 0 would be either 6 or negative 6, because e to the 0 is 1. But if I want it to be a positive 1, I would need positive 6 minus 5. So it should be the positive version of it. And the answer is y equals 6e to the x to the 4th over 4 minus 5. All right, so again, this isn't the exact numbers that you have. I know, I did that on purpose. But this is the exact steps you'd have to solve. So when you're solving your separable differential equation, refer to that. Okay, on the back, there's multiple choice. Only a couple things I want to mention. No calculator on 1, 2, 3, so make sure you're showing enough work for me to believe that you didn't use your calculator on those. If I think you did use your calculator, you'll lose some points. And the only other one that I thought was worth mentioning was number 5. Water is pumped into an empty tank at this rate. Approximately how many gallons have been pumped in the first 5 minutes? Okay, so you might have different numbers here. I'm not sure. There is definitely more than one version of this take home out here. So if this isn't what you see, just realize that there could be other versions. Anyway, if I'm given a rate and I want how many gallons in the first 5 minutes, I don't plug 5 into the rate. That's not what it's looking for. This is the calculator section, by the way. If I want to know how much was in the first 5 minutes, I would essentially want the amount at 5 minus the amount at 0. How much was there at 5? How much was there at 0? But again, this is the rate. This is not the amount. How would I get the amount? Well, if this is how much the amount is changing, the rate that the water in the tank is being pumped in, and if I want the original amount, I would take the integral, right? So since this is a calculator one, you could do it without, but take the integral. What would you want your bounds to be if I want the first 5 minutes, 0 to 5, of that rate dt? Okay, that's all the hints I want to give you, but I thought that would be good to mention since that could be tricky. Good luck. Let me know if you have other questions.